The title of the paper which I am going to present is Structural Design of the Radar Station of Besna, Kobila, Serbia, written by following authors: Miroslav Bešević, Martina, Vojnić, Purčar, Ljiljana, Kozarić, and Smilja, Bursać. In the presentation, I will present you the design project of new radar station. It is located at the top of Besna Kobila mountain in Serbia at an altitude of approximately 1,904 meters. The micro-location itself is a nature surface and with its natural characteristics meets the basic prerequisites for the construction of buildings with a suitable plateau. The planned plateau, whose approximate dimensions are about 55 per 30 meters, in addition to providing space for setting up the facilities, also provides the space needed for parking vehicles, as well as the required area necessary for specific technology when assembling or lowering the radar dome for installing or repairing antennas. The construction of the building is reinforced concrete. The building consists of ground floor and first floor with technical and other areas. From the second to the sixth floor, there is a communication central reinforced concrete floor. At the level of the sixth floor, a platform was formed for storing equipment and supporting the antenna dome with the diameters of 15 meters. At elevation of 24 meters, an antenna mechanism is installed. The equipment girder is calculated on the load from the base of antenna mechanism of intensity 20 km as a constant load. The load from the equipment of intensity 70 km was taken into account. The load from own weight of the structure is calculated in the tower program. A total height of the building with the dome is 37 meters. Horizontal floor structures are in the form of reinforced concrete slabs supported on a reinforced concrete wall 20 cm thick, columns of different dimensions, and a system of reinforced concrete beams of different cross-sections. The vertical construction consists of load-bearing reinforced concrete columns, external and internal concrete walls. The foundation of the building is on a reinforced concrete slab and reinforcement capitals under the columns. In the figures, we can see ground floor and the roof base of the mentioned structure. And in the following figure, we can see the 3D model of the structure. Structural design was performed in software program Tower. The 3D model is shown in figure. Construction calculation is performed for loads from own weight, constant load from materialization of the building, loads from equipment and payloads, loads from snow and wind according to official data of competent meteorological services, which are part of the project task, and seismic loads for earthquakes. For the construction project, based on the data of the investor, an average wind speed of 70 meters per second was adopted. The design of the dome shows the load of the dome according to Eurogrid. The structure is calculated in the spatial system in order to obtain a realistic horizontal displacement and to determine whether their intensity affects the function of the structure. Local elements, external antennas, etc. will be calculated individually and as a whole, and this will be relevant for dimensioning the supports of these elements. The dimensioning of the structural bearing elements was carried out for the authoritative influences according to the load combinations. In the following figure, we can see the plan of formwork and reinforcement. For the conclusion, we can say that the influences on the construction of the radar station are analyzed in detail and the optimal dimensioning of reinforced concrete and steel structural elements is performed according to the load, dominant influences from the wind, with the prescribed displacement and rotations for the relay station. Thank you for your attention.